Academic researchers build robust theories that often sit unread on library shelves. Across the divide, developers in the tech industry forge practical software and machinery, often without understanding the exact mechanics of why their creations actually work. Building a bridge between these two spaces requires engineering and innovation that solves an immediate, tangible problem, while also carrying the weight of deep, peer-reviewed academic rigor. The core of this divide comes down to differing objectives. Traditional science asks, what is the truth? Design and engineering ask, what is useful? To answer both questions simultaneously, researchers rely on a structured methodology known as design science research. Traditional scientific observation documents the world as it already exists. Design science research actively engineers the process of practical problem-solving into a set of verified, repeatable steps, ensuring that what we build also expands what we know. Design science research operates as a rigid architectural blueprint. It provides a strict sequence to forge abstract ideas into viable, tested solutions. This diagram outlines the blueprint's standard sequence. It breaks the research process down into 6 distinct phases, starting on the far left with identifying a real-world problem and ending on the right with communicating the final results. Once objectives are defined, the workflow moves into the design and development phase. Here, the physical creation, the artifact, is built. The framework then pushes that artifact out of the lab to demonstrate utility, rigorously evaluate performance, and publish findings. Crucially, the sequence builds in the ability to step backward. If an artifact fails evaluation, these iteration loops mandate a return to the design phase. This structure doesn't replace the spark of invention, but it organizes the search, turning trial and error into a documented, academically sound engineering process. In the fast-paced tech industry, new tools frequently fail upon release because they lack systematic, phased evaluation before they scale to the public. This model illustrates how design science research handles that risk, using a 4-node evaluation cycle designed to catch flaws both before and after the artifact is physically built. The top half outlines ex-ante evaluation, the stress testing of ideas and designs before committing time and money. The bottom half maps out ex-post evaluation. Once the artifact is instantiated, meaning deployed in the real world, researchers gather rigorous usage metrics to see how it performs under actual pressure. These continuous feedback loops feed directly back into the design phase. Instead of hiding failures to protect a project timeline, the process actively hunts for flaws to force necessary redesigns. This evaluation cycle acts as a safety net. By the time a solution is fully deployed, its utility has been measured and validated against real-world data. Once the evaluation is complete, the artifact works perfectly, and the immediate problem is solved. What is the actual end product for the researcher? A functional application fixes a single issue for a specific company. But in design science research, that physical tool also serves as the evidence needed to extract something more valuable, a generalized theory that others can use. This chart diagrams the dual-layered research output. The top layer represents the immediate project environment, where a specific problem matches a targeted solution. The extracted insights and design theories are then funneled downward through these pathways, enriching our permanent global foundation of understanding. Design science research offers a mechanism for progress because it provides the structure for every localized, practical invention to leave behind a theoretical blueprint for others to build upon.